In this video, we'll talk about how to solve systems of quadratic equations. So I have a couple examples for us to work through here. Let's check out the first one. We have y equals x squared plus 18x plus 35, and y equals negative x squared plus 2x plus 5. So we want to figure out for what values of x and y would make both of these equations true. So the way that we can do that is we can start by setting these two equations equal to each other. So we'll say x squared plus 18x plus 35 is equal to the second equation, so negative x squared plus 2x plus 5. And now we want to move all of these terms on the right side over to the left side of the equation. So we want to get everything on one side. So we'll write, so we have negative x squared, we need to add an x squared. So over here we'll get 2x squared. And then this 2x right here, we need to subtract the 2x to move it to the left-hand side. So 18x minus 2x, that will be 16x. And then we have this 5 right here, so we need to subtract this 5 to move it to the left-hand side. So 35 minus 5 is 30. So this whole left-hand side will be equal to 0. And now we need to factor this left-hand side to figure out what values of x will make this left-hand side equal to 0. So before we do that, it looks like we can pull out a 2 from each of these terms. So let's do that. We'll have 2x squared plus 16 divided by 2 is 8. 8x plus 30 divided by 2 is 15. Is equal to 0. So now we need to factor this portion in the parentheses here. So the way that we do that, if you'll recall, is we want to remember, or we want to think of what values multiply to 15 but add to 8. So that would be 3 and 5. So we can write 2 times x plus 3 and x plus 5. So that's how we can factor these parentheses into these two smaller parentheses. And then we just need to figure out for what values of x would make this left-hand side equal to 0. So the way that we can do that is we can say x plus 3 could be equal to 0, or x plus 5 could be equal to 0. And we can see that if x was negative 3, this whole thing would become 0. And over here, if x was negative 5, this whole expression would become 0. So we solved for our two x values. Now we just need to figure out what y values correspond to them. And the way that we do that is we just plug these x values into either one of these equations up here. So we'll choose the first equation. So let's say we'll plug in a negative 3 for x. So negative 3 squared plus 18 times negative 3 plus 35. So negative 3 squared, that's 9. 18 times negative 3, that's negative 54. And then we have plus 35. So 9 minus 54 plus 35, that turns out to be negative 10. So that would be the y value that corresponds to this x value of negative 3. Now to figure out the y value for the x value of negative 5, we can do the same thing. So we can plug it into either one of these equations. We'll choose the first one again. So we'll say negative 5 squared plus 18 times negative 5 plus 35. So we get negative 5 squared is 25. 18 times negative 5, that's negative 90. And then we have plus 35. So that turns out to be negative 30. So our final answers are negative 3, comma negative 10, and negative 5, comma negative 30. These are the two xy coordinates that make both of these quadratic equations true. Now, if you were to graph these two quadratic equations, it would look something like this, and this won't be drawn to scale, but just to give us an idea. The x squared plus 18x plus 35, that would be a parabola that goes up like this. And then the negative x squared plus 2x plus 5, that would be a parabola that goes something like this. And what we just found is these two parabolas intersect at these points, negative 3, negative 10. So again, this is not drawn to scale at all, but we'll write negative 3, negative 10. And the other intersection point is negative 5, negative 30. So somewhere down here. -5, -30. That's what these two xy coordinates really tell us. So that's how we solved for that one. Okay, let's try one more example. Let's say we have y equals x squared plus 3x plus 2 and y equals x squared plus 5x minus 4. How can we solve for the xy coordinates that will make both of these equations true? So remember our trick. We just start by setting both equations equal to each other. So we'll say x squared plus 3x plus 2 is equal to x squared plus 5x minus 4. The next step is we want to move everything from the right-hand side over to the left-hand side. So for example, we want to subtract x squared. So we'll get x squared minus x squared, so those two just cancel out. And then we subtract 5x. So we'll get 3x minus 5x, that's negative 2x. And then we get this negative 4 over here, we need to add that positive 4. So 2 plus 4 is 6. So we get negative 2x plus 6 is equal to 0. So to solve for x, we could move this negative 2x over to this right-hand side. So we would get 6 is equal to 2x. And then to solve for x, we can divide both sides by 2. So we get x is equal to 3. So in this example, there's only one x solution. Remember the last example, there were two. So in this particular example, to figure out what y value corresponds to this x, we can just plug a 3 into either of these equations up here. So let's plug it into the first equation. So we get 3 squared plus 3 times 3 plus 2. So 3 squared is 9, plus 3 times 3 is also 9, plus 2. So 9 plus 9 is 18, plus 2 is 20. So this is our y value. So our final solution will be 3, 20. These are the xy coordinates that would make both of these equations true. Now if we were to visualize the results here, these parabolas would look something like this. And again, this is not drawn to scale at all, but just to give us an idea of what we just found. Our two parabolas will look something like this, where there's only one point of intersection, and it happens right here at 3, 20.